Operating system is a set of programs that acts as an intermediate between the user and the computer. There is a lot of operating systems, and Unix and Windows are ones that are famous. Unix is an operating system that has been constantly updated since it was developed. It is a powerful multi-user system that allows multiple users to share the same resources, and it is also a powerful multitasking system since it allows a user to run multiple processes in a time. Meanwhile, Windows is a famous graphical operating system which it is using graphical user interface. Up until today, there are various versions of Windows such as Windows 7, 8, 10, and the current release is Windows 11.
Now, I'm going to explain about the difference of interprocess communication between Unix and Windows. Interprocess communication is the operating system technique for allowing processes to communicate with each other. Communication could be as simple as a process informing another process of an event that has occurred, or it could be as complex as data being transferred from one process to another. Pipes are a simple synchronized way of passing information between two processes. Both Unix and Windows have effective pipe implementation that are superior in their own right. The Unix implementation is fairly easy to use, whereas the Windows implementation is quite difficult in comparison. But it provides the programmer with a lot more flexibility. Because of the wealth of data available at runtime, sophisticated servers capable of managing multiple clients can be built. A good feature is the ability for pipes to switch between being synchronous and asynchronous. Windows also supports numerous pipes out of the box, doesn't limit the use of numerous pipes to related process, and supports bidirectional communication over a single pipe. Pipes provide a reliable way for IPC in both operating system, and the two parties can verify data received in real time. Socket also is one of IPC mechanism. It is one endpoint of a two-way communication link between two programs running on the network. A socket is bound to a port number so that the TCP layer can identify the application that data is destined to be sent to. The WinSock API, which implements Windows Socket, provides a decent programming interface for peer-to-peer communication. The WinSock API is a high-level, simple-to-use programming interface that is well suited to the Windows platform. When utilized with overlapping input-output, it has the highest data transfer rate of any peer-to-peer technique. It is superior to regular Berkeley sockets since it provides protocol independence as well as protocol transparency when used with the Service Registration API. With a few minor exceptions, it provides all of the functionality of the Berkeley socket package, typically in the same fashion. Migrating code from Berkeley socket to Windows benefit to programmers, including the Service Registration API, overlap input-output, the choice of synchronous or asynchronous input-output, quality of service support, and computation port, in addition to natively supporting protocols not supported by Berkeley socket.
Assalamualaikum warahmatullahi wabarakatuh. My name is Faeez bin Farizal, and I will be explaining the differences between Unix and Windows in terms of process and threads. So starting off, Unix uses the fork method to create a process, while Windows uses the spawn method. In Unix, when you fork a process, a child process is created as a clone of the parent process, but with a separate address space. While in Windows, when you spawn a process, a child process is just created and executed, hence the word spawn. We can see this in the pictures. So when you fork a process, there goes a parent process and then there goes a child process. And in spawning from Windows, you can just spawn 3 different processes, and then you have 3 child processes. For threads, Unix does not have a concept of threads. It just treats threads as a process, and everything is just an executable task. Meanwhile, in Windows, it has a concept of threads. Unix supports multiprocessing and Windows supports multithreading. So what is multiprocessing and multithreading? Multiprocessing is also called process forking, and it utilizes the program by using more resources and memory. So that means that processes and resources are shared between all the processor cores in a single CPU. And multi-threading is just creating many threads from a single process, and then all those processes are executed simultaneously. And the good thing about threading is that threads share the processing power of a core, CPU cache, and transition leukocyte buffer. So a single CPU core can manage to do all these threads. Meanwhile, in multiprocessing, the processes are all shared between all the processors. So we can see in the picture that multiprocessing, you have a main process, and then it is divided between 3 processes, and it all uses the same amount of CPU power and memory. Meanwhile, in multithreading, you have the CPU and the memory, and then the CPU decides how much power each thread is going to use. So that's the main difference between Unix and Windows in terms of threading. That's all from me. Thank you.
Unix and Windows also differ in terms of CPU scheduling. CPU scheduling is a technique that allows one process to use the CPU while the other process's execution is waiting in the ready queue. Ready queue is actually a set of all processes residing in the main memory, ready and waiting to be executed. So firstly, for the Unix, it is actually using the multi-level queue with round robin as its scheduling algorithm. Its ready queue is partitioned into separated queues of foreground, which means it is interactive. This is actually beneficial for the interactive user since it is providing good time of response, and it ensures there will be no starvation for low priority background jobs since the priorities are always adjusted. If the current running process is in the user mode, the non-running process with a higher priority will preempt it immediately, or otherwise it switches when the current process exits the kernel. In the other hand, Windows is using priority preemptive scheduling algorithm as its CPU scheduling, which means the scheduler will make sure the thread or process with a higher priority will be always running. The dispatcher, who controls the scheduling, will determine the order of execution of the thread using the 32-level priority scheme, which these priorities are divided into 2 classes. The first class is called as variable class, which ranging from 1 to 15, and then the second class, which is called as a real-time class, ranging from 16 to 31. There is also a thread that will be running on a priority of 0 that it is used for the memory management. The dispatcher actually uses queue for each scheduling priority, and the dispatcher will check from the highest to the lowest, and it will select one ready thread to be executed. If there is no ready thread, the dispatcher will execute a special thread called as idle dispatcher.
Hi, my name is Hanis Syakirah binti Roslan. I will proceed with synchronization. Synchronization is a mechanism used to ensure the mutual exclusion processes to maintain data consistency, and it occurs in Cooperating processes. Cooperating processes is a processes that execute the same shared data at one time, and the execution can affect other processes. There are two ways to share data. One, it can share data through files and messages, and the other one, it can directly share a logical address space. Concurrent access to shared data may lead to data inconsistency when there are multiple processes that trying to execute the same shared data at the same time. Hence, multiple mechanisms are used to ensure that processes that share the same data, that use the same shared data at one time, can execute in a sequence in order to avoid data inconsistency. In Unix, synchronization is used as a time slice for each process to be executed. The Unix system will read and write the data into a memory using buffer cache to avoid data to be transferred into secondary memory. To increase performance by avoiding slow write-up process into secondary memory more often than necessary. On the other hand, Windows use a multi-threaded kernel that provides support for multi-processes. Windows use interrupt masks to protect and access into global resources using a spin lock. Windows provide dispatcher object for thread synchronization according several different mechanisms, mutex such as mutex, semaphore, and so on. The system protects shared data by requiring a thread to gain ownership of a mutex or accessing the data, and when it's finished processing, it's released the ownership. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurain Syamimi Nadia binti Muhammad Naszeri, and I will continue the presentation with memory management. First of all, memory management is defined as a type of resource management that is used to manage computer memory. The most basic requirement of memory management is to offer ways for dynamically allocating memory to programs at their request and release it to be reused when it is no longer required. The difference of the memory management between Windows and Unix are: firstly, Windows manage the virtual memory using tree data structure, where the tree have nodes and each node is called a virtual address descriptor or a VAD. Each node in the tree is labeled as either free, reserved, or committed virtual memory by the VAD. A process can be stored in memory or set aside for a later use. Unix, on the other hand, uses a linked list data structure that starts to search whenever a page is discovered and then records the address range, protection mode, and also growth direction. Other than that, Windows uses cluster demand paging, which means that pages are only allocated to memory when they are needed. Other than that, instead of bringing in parts of page one at a time, Windows will load a complete page into a memory at once. Windows use memory relocation method called first in first out, where the oldest or the first entry is processed first. Meanwhile, Unix manage memory relocation through demand paging, which prevents any unneeded pages from being swept into memory. The operating system will be able to avoid or does not read pages that are not currently in use if this method is utilized. The algorithm used is called the least recently used algorithm. Now I will continue with the file system. First of all, what is a file system? A file system is a mechanism and data structure used by the operating system, which is responsible for file management, where it controls how data is saved and accessed in computers. It also provides a way of storing data and gaining access to the contents of files, including data and programs. The difference between Windows and Unix for the file system is that Windows uses file allocation table and new technology file system to manage the files. Meanwhile, Unix uses UFS or Unix file system. For Windows, the files are saved in folders on distinct storage drives, and for Unix, it views all physical drive as a single logical drive, and it also have a dependable and effective file system, and is represented as a hierarchical tree under the same root. Other than that, on Windows, application might store all of its files in one location. For example, the application files can be found in program files, and for Unix, the file might be split into multiple locations. For example, the binaries can be found in user/bin, the libraries is inside user/lib, and the configuration is inside the /etc files. And that's it for me. Thank you.